Hi, I'm Miss Hall, and in this lesson we're going to talk about compound Boolean expressions. We'll begin by talking about what comparative operators we have to compare two values or two variables. Let's begin with the double equals. Double equals means is equal to. So let me put x is equal to 3, and then let me put a couple of x values. So in this case, if x is 3, then x is equal to 3 is true. And if x was, say, 10, x is equal to 3 is false. We're going to keep using x and 3, and now we could do not equal to. So x is not equal to 3. So in this case, when I make this first column, x is just going to equal 3 and x is going to equal 10. So this first column, if x is 3 and the expression is 3 is not equal to x, that is false because x is 3. And when x is 10, x is not equal to 3 is true. Let's compare x and 3. Now with your inequality symbols that you know from math class. Less than, equal to, greater than, equal to. Okay, so for each of these, let's go through. If x is 3, x is less than 3 is false. If it's 10, 10 is less than 3 is also false. Then we have x is less than or equal to 3. When x is 3, well, it's equal to, so this is true. When x is 10, 10 is less than or equal to 3, that is false. Then we'll do x is greater than 3 when x is 3, that's false. X is greater than 3 when x is 10, that is true. Let's do x is greater than or equal to 3 when x is 3, that's true. X is greater than or equal to 3 when x is 10, that is true. Okay, so we've reviewed those. Let's add, you could have an exclamation mark on the outside. So let's just take this top one and add an x. So not x is equal to 3. So what we do is we first take x is equal to 3, and in the first case when x is 3, that's true. And then this exclamation point on the outside means not. So the result here will be false. So if we do 10 for x and we have 10 is equal to 3, well, that's false. But then you have the exclamation mark on the outside, which says not false, which is true. And the only two symbols that I am missing, and I'll write them on the side, they were in the previous lesson, and that is the double line means or, and the two ampersands mean and. Compound Boolean expressions level 1. Given the following Boolean expression with a numerical variable x, answer the question below. X is less than 3, and our three choices in the drop-down are this is always true, this is always false, this can be true or false. Anyway, x is less than 3. Well, let's give some x values. And so x could be, let's say, 0, could be 3, could be 5. And now we'll test it in the expression. We have 0 is less than 3. Well, that's true. 3 is less than 3. That's false. 5 and less than 3. That's false. So this isn't always false, and this isn't always true, which means the correct answer is that it's sometimes true and sometimes false. Compound Boolean expressions level 2. Given the following Boolean expression with a numerical variable x, answer the question below. X is equal to 8 and x is greater than or equal to 4. So I'm just going to note, so I know for and, both of these need to be true for the result, the and, to be true. Let me try some x values, and we'll be testing if x is equal to 8 and if x is greater than or equal to 4. So let's try. So if x is 8, then 8 is equal to 8 is true, and 8 is greater than or equal to 4 is also true. So the and, when you put true and true together, you get true. What if x was, say, 1? Let's try this. So 1 is equal to 8, that is false. 1 is greater than or equal to 4 is false. And when I do false and false, I get false. Okay, so I've already proved that it's not always true and it's not always false, so let's fill in this example. If we select the expression can be true or false, when x equals something, the expression evaluates to true. Well, we have an example when x equals 8. When x equals something, the expression evaluates to false. Well, we just did an example with 1. Compound Boolean expressions level 3. Given the following Boolean expression with numerical variables x and y, answer the questions below. X is less than 5 or y is not equal to 5. With this OR gate, remember there are 3 scenarios where OR is true. We can have true and true, true and false, or false and true. Okay, so let me make a little table of possible values. Not equal to 5. We want to test the OR. Okay, so for OR to be true, let's kind of work backwards. So if I want the goal to be true, let me find one where y is true and x is false. So if x is, say, 10, 10 is not less than 5, so that's false. I want this statement to be true. Y is not equal to 5 to be true. Let's make y 1. 1 is not equal to 5, and here's a scenario where we've made this expression true. Now let me try to make the expression false. So for OR to be false, the only way to make an OR gate false is for both parts to be false. So I know that 10 is x, makes x is less than 5 false, and I need something that makes y false, and there's only one value. 5 is not equal to 5, that's false. So my examples, the expression is true when x equals 10 and y equals 1. And the expression is false, for example, when x equals 10 and y equals 5.